What is up, everyone? My name is Max Curry, and I'm the creator of Death Cassette Games. In our last video, we made an announcement on the change to our schedule for release on video. We are now releasing on Tuesdays and Thursdays. I also announced that we were going to be starting a new video series on landscape deformation. And it's going to be a 3-part series, and it's a little complicated. It's not my tutorial. I didn't come up with it. The original one that I found was by Tommy Tran on Codeco, and Prismatica Dev on YouTube pointed me to it in one of his videos. Tommy's tutorial is in UE4 and I'm in UE5, so some of the systems are a little different. Since then, I found some other ones and I've pieced it together to get a working tutorial. And this will be the 5th time that I have tried to record this, and hopefully this time I won't mess it up. So, yeah, roll the intro. Alright guys, we are in UE or Unreal Engine. This is edition 5.3. If you've been following along, you might recognize this sandbox world that we've created to test some of our systems as we develop them. One difference is now we have a big landscape. I say big, it's not that big, but we have a big landscape, and that's what we're going to be working on today, is a landscape deformation system. It's a little complicated, but let's get into it. So the first thing we're going to do, now that we have our landscape, is we're going to set up some organization by creating a new folder in our system, and we're going to call this Landscape Deformation. In here, we're going to make a couple of other folders. We're going to start with a blueprint. That's not how you spell that. Blueprint folder. It's weird. Can't see. Material folder, and a texture folder. Let's start with our material. We're going to go in that folder and we're going to create a new material. We're just going to call this one Landscape. All right, open that up, and we're just going to start with a base color. We're going to get a constant vector 3. Let's make it a nice brown color. It's not really a very nice color, but whatever. We'll plug that into our base color. I'm going to apply, save. Drag that up into our tabs, and now we want to assign it to our landscape. If I could find it wherever I put it. There it is. All right, I'm gonna assign it to the landscape material. All right, nice orange brown. Okay, the next thing we want to do is we want to create an actor. We're going to call it capture. Go ahead and open that up. And in this, we're going to get a scene capture component 2D. We're going to change the rotation on the Y to 90, on the Z to 90, so it's looking up. We're going to change the projection type to orthographic and the ortho width to 2048. Now, From here, we need to get in this post-process volume in the render features, we need a post-process material. So we'll compile and save, go back into our material folder and create a new material. And we're going to call this one depth check. We don't want this material domain to be surface. We want it to be post-process volume. And what we're going to do is we're going to get a scene texture. We want this scene texture ID to be custom depth. We'll duplicate that. And we want this second one here to be scene depth. From here, we want to get a mask. We want it on the red channel only. We're going to duplicate that one. Plug that in here. And now we're going to subtract. Subtracting the custom depth from the scene depth. And now we're going to divide. We're going to divide it by 15. This is defining the height from the floor that this is going to check. We're going to get a saturate and a 1 minus. We're just going to plug that into the emissive color, apply, and save. Now, what we're going to do is I'm going to select these objects here, and you want to search for custom depth. So you're looking for the render custom depth pass. Make sure that's turned on. And now what we're going to do is we're going to go all the way up and we're looking for our post-process volume. We are going to do material. And this post-process material, we want to assign this depth check just to see if we set it up right. Okay, so now everything is black except for the objects that we put the custom depth render on. Okay, let's return that back to normal. Let's go back into our landscape. You want to make sure that your landscape is two-sided. So let's add that in there. And now back into our BP capture, we need to assign that material as our post-process material. There we go, depth check. Now we need a texture target for this. So we're going to compile and save and go back into our content drawer. We're going to go into our texture folder and we're going to create a render target. We're also going to call this one capture. Now we can assign that as our texture target. Okay, compile and save. Now, we need some stored parameters for our material. So we're going to go back into our material folder and we are going to create a material parameter collection, MPC capture. So in here, we need a couple of scalar parameters and a vector parameter. So we'll start with our first scalar parameter. We're going to name this one capture size. We're going to add one more. We're going to call this one height. This is going to come in handy later. And then our vector parameter, we're going to call it capture location. Save that and go back to our landscape. Now this is where, I know I've been bouncing around a lot, but there's reasons. So now what we're going to do is get into some of the more complicated stuff. So over here, what we want to do is we want to get a world position. And off of this, we're going to get a mask. And we want to multiply it. So we need some values here. So we're going to get a constant 2 vector. Put that in here. Our values, we want the x to be -1 and the y to be 1. Now we need to add. And from this add, the collection we just made, we're going to call that, and we need this to be our capture size. We're going to divide that by 2 and plug it in right here. Now off of this add, we want to get one more divide, and we want to plug this in here as well. Okay. Now we need a custom node. So right click and type in custom. We want this to be, we want the output to be a float 1, and the input name we're going to put as UV. Now we need to add some code, so that it needs to read like this: if open parentheses UV dot x less than 0 or UV x greater than 1, UV y less than 0, or UV y greater than 1. Now we need to add some lines to this, so we're going to hold shift and hit enter. We need an open curly bracket. Hold shift, hit enter, return 0. So if it's true, return a 0, add a line, add one more line, and else return 1. Okay. So we'll plug that in right here. Now we need to get a texture. So we created a render target texture, and we're going to plug that in. And then from here, we need to get a multiply. Plug our texture sample into that as well. So now our custom node and our texture sample are being multiplied. From here, we're going to get a 1 minus, and we will plug that into our base color. Click apply. Let's go back to our capture. We need to add some functions on our event graph, but before we do, I want to make sure, once you add your target material here, you also want your capture source. I forgot to do this, but you want your capture source to be final color. Now, on the event graph, we don't need these. So on event begin play, we want to set a scalar parameter value. We want this to be the collection we just made. We want it to reference the capture size. Now for the parameter value, what we're going to do is drag in our scene capture component, and we're going to get the ortho width and plug that in right here. File, Save. Now we need some functions. So we're going to add a new function. We're going to call it move capture. And we need a macro. So this one we're going to call snap to pixel world size. And now in that macro, we need some inputs. So we're going to add our inputs over here, just like we do our variables in our event graph. We need them to be of type float. The first one we want is player X. Then we want our player Y. And then we're going to define our pixel world size. Okay. Now, from here, off the player X, we need a divide function. And we're going to divide it by the pixel world size. And off the player Y, we're going to do the same thing. Divide it by pixel world size. And off of these, we need to get the floor node. And now we need to make vector. We're going to plug this into our X, and we're going to plug this into our Y. Now we need to get an add function. And we want to turn this into a float, and we want to add 0.5. And then we're going to multiply. We want to multiply by our pixel world size. And then we need our outputs, so we're going to plug our multiply into our outputs to return this. Compile, save. Now we need to go back to the move capture function we just created. And we need to create a variable for this. We need a move offset. And it needs to be a vector 2D. We're gonna set that off of our move capture. We need some room out here. So the first thing we're gonna need is we're gonna need our get player character and get actor location. We're going to split this struct pin, and then we're going to drag in our new macro. And we're going to plug the X into the X and the Y into the Y. And for our pixel world size, we are going to drag in our scene capture component, get ortho width, and we're going to multiply this. What we want to multiply by is a divided value, so we need our divide. We want this to be 1 divided by 256. And then we're going to plug that right into our pixel world size. So now we need to subtract. We need to get actor location. We're going to plug that into this. So we're subtracting the actor's location from our returned value here. We're going to split this struct pin, and we're going to split this one. So we're going to plug the returned X and Y into our move offset variable. Now we need to add actor world offset. We're going to split that, X to X, Y to Y. Compile and save that. Now let's add, well, let's first check this out. So let me make sure that our side-scrolling character has the custom depth render turned on. They do, okay. And then let's make sure we add our BP capture. We want to set this actor's location to 0, 0, negative 2000. So it's way down there. Okay. So now that that's there, let's add some contrast to our landscape by adding additional colors. So we'll duplicate this. We're gonna do a Death Cassette Games hot pink. There we go. And then we're gonna get a lerp, linear interpolate. And then from this one minus that's plugged into our base color, you want to plug that into the alpha. And then we're going to plug that into our base color. Apply and save. So now if I drop the player character in here and hit play, it doesn't really appear to be working, but that's because right now the location of the offset is only in a certain location, and it's actually at 0, 0, or 0, 0, 0 rather. So we're not going to see it over here. So what we need to do is we need to go back into our BP capture. Off of the add actor world offset, we need to set vector parameter. We're going to set this to our collection, and we specifically want the capture location. So now we need to get actor location, and we're going to plug that in as our parameter value here. Now that's not going to do it alone. We need to go back into our landscape, and we need to subtract it from here. So from here, we need to subtract, and we need to get our collection. And we need to subtract the capture location from here. So we're gonna mask this, plug it in right here. And we'll plug that in right here. Apply and save. Now we need to go back into our BP capture, into our event graph, and we need the event tick. So we're going to take this function of move capture and we're going to put it on the event tick. Compile, save, and now it's kind of hard to see from here, so we'll eject. But you can see we've got some pink around the bottom of our feet, and you can see the pink on the bottoms of these objects that also have the render pass. Ouch. So that's working perfectly.